In this video, we are going to kick off the security section for the route exam. What we're going to start off talking about is just a high-level picture of AAA and a couple of the configuration options that are available to it. And then we'll take a look at going in and setting up configuring and verifying device access control. So I'll basically show you guys how to go in there and manipulate how to get basically Telnet and SSH configured and operational, and then how to secure it to make sure that only specific subnets are able to reach the router or the switch via Telnet or SSH. And then we'll wrap it up by taking a look at access lists and unicast reverse path forwarding is basically what we're going to start finish up with. This isn't going to be a long video, so there's not a ton to cover, so we're just going to go ahead and dive right into it. Now, with AAA, or the authentication, authorization, and accounting capability inside of iOS, basically this is a enhancement to the standard way of handling authentication. So when you go in, AAA typically is going to default back to some sort of external server. So like for instance Radius or TACACS, and then that's going to allow you to turn on network policy server on your server 2008 or 2012 box, and then from there tie that to Active Directory to determine who can do what, where, and when, and how, and all that good stuff. So the old model of AAA, so AAA old model was just local authentication, local authorization based off of the line and username settings. It was just local authentication. So you had to have a local database configured. With AAA new model, that has been removed, so now you have the ability to actually reach out to an external authentication and authorization capability, like Radius or TACACS, and to be able to get that operational. So beyond that, that's pretty much the main difference between them. So when it comes down to setting up Radius and TACACS with AAA, you would simply go in and enable the configuration. So let me go over some of the details for this so that it makes a little more sense. AAA new model would give you several different capabilities that you'd be able to work with. So the first one we're going to talk about is authentication login default group. Basically what this means is if you have a authentication login default group, AAA authentication login is simply stating when you go to log into the box, what is going to be the default, the method for you to connect into the box. So login default means there's these things called method lists. The method list basically is you can either use the default method list or you can create a custom one. We're going to use strictly the default one, and then we're going to specify after the default one how we're going to authenticate you. Are we going to authenticate you with a group, which means are you going to reach out to Radius or TACACS? And if you do use the group, it's highly recommended that you also enable the local command at the end of that. So that's that AAA authentication login default group, this TACACS local command, which basically means is you're first going to use the TACACS server to authenticate your connectivity, and if TACACS is unavailable or you can't reach out to it, then you're going to default back to the local database, which prevents you from getting locked out of the box. So if AAA for whatever reason can't reach the Radius or TACACS server, and you need to gain access to the box, and you don't have the ability to do so, you're going to be locked out. So the best thing for you to do would be to enable login local. Normally what I do is since I don't ever have a TACACS server running locally, I always type in AAA authentication login default local, and that takes care of all the problems I might have. Now underneath the line, if you want to enable this, you would go underneath the line and type in for doing the local database login, you would simply type in AAA authentication login, the group name, and then away you would go. So that's how you would go in there and connect into the box. If you're not using AAA at all, you could simply create a username and password, and then simply go to the interface, to the line console 0, line VTY 0 space 4, and simply type in login local, and it would check the local database for you to log in. So that's just a couple of the capabilities that are out there for you to get on the box and get everything situated. So as long as you have, if you decide to go and use Radius or TACX to connect into the box, make sure that you have some way of defaulting back to a local database so that you can still gain access to the box in case that AAA for whatever reason might be down. I shouldn't say AAA. AAA will actually never be down unless you disable it, if your Radius and TACX is unavailable for whatever reason. So that's the main thing you want to pay attention to. The next thing we're going to talk about is going to be configuring device access via the lines in the VTY and the aux and the console port. Then we'll talk about management plane protection and then password encryption. So let me pull this guy down, and we're going to take a look at this. Now, this is pretty much, I haven't messed with anything since I shot the last IPv6 video for BGP. So I'm going to just walk you through some of the configuration here to get, say for instance, router 1 configured. So we're going to go to global config, and for line VTY, if we type in do show run pipe section line, you're going to have several configure. That's not going to pull up anything. INE. Alright, so right now the way we have it set up is for line console 0, we're set up to log in as privilege mode 15, logging synchronous is on. Logging synchronous simply means that when you exit out of global config and this thing pops up right here, this syslog message stating that you just came out of global config mode, it was configured from console by console. Basically this means is I'm consoled into the router. This would be the same thing as if I had a console connection. If I had a telnet connection to it, you wouldn't see this unless you turned logging on to a debugging level, or you had logging or terminal monitor on, things like that. So the idea here is when you're setting up your line VTY or your VTY aux or console ports, you want to make sure that you have them set up correctly. So you can go up here and say, for instance, we're going to say in AAA new model. Let's say in AAA authentication is going to be login, and we're going to say default, and we're going to say local and question mark, and then we're going to hit enter. So what that means now is if I try to telnet to myself, so let me type in do show IP interface brief. If I try to telnet, do telnet to this guy, it's going to say Rob and Cisco, and authentication failed. So what I need to do now is I need to hit the enter key. Now I'm stuck. I have to wait for it to bug out before it'll let me do anything. So there I am. I'm back to where it was. If I type in do show run pipe section user, nothing's configured at the moment. So what I would need to do is I need to come in here. I would have to come in and say username is Rob and my privilege mode is privilege 15, and my password is going to be a secret, and it's going to be Cisco. Okay, now if I go, and what I need to do now is I need to go underneath the line VTY 0 space 4 and type in login question mark is authentication. This means AAA is running, and I need to type in default and say that's what it's going to use. So now if I exit out of here and type in do telnet again, it'll be Rob and Cisco and enable, and see, I'm not. What basically this is telling me is I haven't given myself enable level access yet. Even though I gave myself privilege level 15 configuration, I didn't give myself enable access. So I have to exit out of here. I have to type in AAA authentication is going to be enable. So right here, see the enable one right there? I'm going to paste that there, enable, and default, and I'm going to say local. The enable password. and then I'd have to configure enable password to do that. Now I could use line password, I could use server group, which would be TACACS or radius. So I'm going to use that. I'm going to type in the enable secret is Cisco. Now if I do that telnet command again, and I type in Rob and Cisco, and question mark, and then type Cisco again, now I'm able to log back in. So that's how you would manipulate that. If I don't want to run AAA, so if I exit out of here, and I come in here, I type in no AAA new model. Yep. So what okay, so AAA is not, I can't roll back to, I can't turn AAA off. So, that's how you would do that. Now, when we talk about configuring access control here, type in do show run pipe section line. What I've done there is just accessing the device. I have a login. Well, I must have taken it out. So do show run pipe section AAA. Oh, it took it out. Okay. So what I'm going to do now is I'm going to type in do show run pipe section user and see if my user configuration is still there. It should still be there. It is. So now what I'm going to do is I'm going to type in line VTY 0 4, and I'm going to type in login question mark is local. So notice how it went from authentication to local, and then I can type in enter, and now it's going to use the local database. If I come in here and type in telnet to 10.1.100.1, I can telnet to myself, use the username and password, and then I'm automatically at enable mode because my username and password are set to privilege level 15. So that's how you would do that. Now that I have that there, I'm going to go up here and configure an access list and say, I'm going to say IP access list standard is going to be 1. I'm going to type in permit 10.2.100.0 0.0.0.255, and I'm going to type it, and then there's an implicit deny all at the end if I don't type anything more specific. But the reason I'm doing this is because of the fact that my addressing is a little bit off. I'm 10.1.100, so if I type in do show IP interface brief, I want to make sure that I can't telnet to myself. So I'm going to type in line VTY 0 4. I'm going to type in access class 1 in. Now if I exit out here and type in do telnet to 10.1.100.1, it's going to be it's refused, and the reason it's refused is because of the fact that I have an access class here. If I type in do show access list, you're gonna well, it doesn't show anything here, but actually, if I type in IP access list 1 or standard 1, and I hit the up arrow to when I type that in, permit, and I permit that one, and then I type in a deny all log, to deny any log, and then I exit out of here and I do that same telnet command again. There, it's telling me that I was deny 10.1.100.1. Type in do show access list. You'll see that I have a deny any log here, so that it prevents me from logging into the box. Another one to take a look at here would be do show run. There's a question, can you do that to the console lines as well? Yes, you can. You can actually do that to any of the lines, as long as you have an ACL to permit something, or to deny something. You can apply that to any of the lines. So line console 0, line VTY, or line aux. So what I'm going to do here is I'm going to type in username is going to be Zig, and the password is going to be Ziegler. Okay, now I'm going to type in do show run pipe section user. you'll see that that is a clear text password, right? What I need to do here is I need to type in service password encryption, hit the enter key, and then hit the up arrow a couple times again, and now Ziegler will be type 7 encryption, because now I have turned on service password encryption. What service password encryption does, it takes any clear text passwords you have in the running config, and it gives them a type 7 encryption. So basically it prevents somebody from eavesdropping on your traffic or potentially learning information that they shouldn't be learning, and it gives you that flexibility. The other one to take a look at here is going to be control plane policing, which is also management plane protection. So if you were to type in control plane here, question mark, and hit the enter key, you can actually apply a service policy to this guy. So it says QoS service policy. So what I'm going to do is I'm going to type in a class map. Class map is going to be class map name is going to be ICMP question mark, and hit the enter key. I'm going to type in match. I'm going to say protocol, and I'm going to say ICMP should be in here, ICMP. Now, what's going to end up happening here on the back end of this router is I'm actually turning on a thing or a feature called NBAR. NBAR is Network-Based Application Recognition. And what that does is it is able to look at the layer 7 of a particular, it's able to look at the application layer of different protocols and say, okay, if I see ICMP traffic come through and I'm matching that, I want to make sure that I don't send more traffic to this device than is needed to if it's ping. Because what you can end up doing actually in a real big environment is if you have enough reachability to a particular router, if you were to send a bunch of pings from a bunch of different devices to a single IP address, and you do it fast enough and long enough, you can actually overrun the CPU. Because it's actually the CPU of the box that's responding to all those pings. Same thing happens if you happen to have a layer 2 loop in your network, and you have a bunch of information just being broadcasted by the switches. What's going to end up happening is, if spanning tree has been disabled or a loop has been detected, what's going to end up happening is that information is going to consistently be sent out all interfaces. Now I've enabled NBAR in the process here. So now what I'm going to be able to do is I'll be able to match ICMP. So now what basically ends up happening with the layer 2 loop is if you are watching this traffic go out, and if you look at the switch, it'll be every interface will be going just crazy and just be flashing really, really fast. You look at the CPU of the device, it'll be spiked to 100% because it's trying to respond to all the broadcasts. And what will actually end up happening is all of that traffic that's going out towards your end users, the end users will be receiving this traffic as well, and then those CPUs will start to spike, because it's not the network card that responds to the ping, it's actually the CPU of the computer, the laptop or what have you, that's responding to the ping. So now that I have this guy here, what I'm able to do is I can exit out of here, and I can type in policy map, and I'm going to type in is going to be the name of it is going to be ping, and I'm going to hit the enter key. I'm going to say class map, or it's asking me what the name of the class map is going to be ICMP, and I get to say here I'm going to police the rate down to a % of the bandwidth for rates. Actually, no, police down to 8,000 bits. I'm going to do that. And now I get to come in here and I get to, if we get to set our limits here. So what I'm going to do is I'm going to say conform action. Action is going to be transmit. And then I'm going to say an exceed action, or a violate action, is going to be drop. Okay. Now that I've got that done, I'm going to be able to exit out of here and type in do show run pipe section class map pipe policy map, and hit the enter key. Now we'll be actually be able to break this down. If you've never seen this before, don't freak out. But basically what I've done is I've gone in and I've created a class map. The class map is always going to be the classifier. What do you want to match against? The class map then says, I want to match based off of ICMP. If you send a ping or a trace route, that's ICMP. I have a policy map that's calling the class map of ICMP, and it's setting a police the committed information rate of 8,000 bits per second. So if I send more than 8,000 bits per second to this router, what's going to end up happening is, or if I send at 8,000 bits per second or lower, that's a transmit, that's a conform action. It conforms to the committed information rate. If I exceed 8,000 bits per second, I'm going to drop the traffic. Now what I would do is I would type in a control plane, hit the enter key, and type in service policy. I'm going to call in an input, and I'm going to call the name of the policy map happens to be ping. And I'm going to hit input ping. Now what that's saying now is anything that comes in here says match NBAR protocol is not supported for this interface. Okay, so basically what it's telling me is I can't. I can actually do this then. I can exit out here and type in class map, ICMP, and I can say match, and I can say I believe I can do I don't know if it'll let me do a port number. I'm looking at the options here. I might actually have to create an access group would allow me to apply an access list. So let's actually do this. Let's exit out of here, type in IP access list 10, standard 10, and we're going to type in match or permit any. Or actually, I need to go IP access list extended 10 or 100 or ping, and I'm going to hit enter. I'm going to type in permit any permit TCP, or ICMP is TCP, right? Yes. Permit TCP any EQ, and up here at the top you have port number. ICMP is actually port 1. Incomplete command any. So I'm going to exit out of here. I'm going to type in class map ICMP match access group ping access group name is going to be ping. It is ping, right? Name is going to be ping, and I'm going to do show run pipe section class map pipe policy map. I just got to make sure I have everything already preset, and I do. So I have ping set up. So what I'm going to do now is I'm going to type in control plane. I'm going to say match or service policy, and it's going to be input on. That is it a button on my computer. I just upgraded to input is going to be the name of the policy map is ping. See, I'm not matching on. Oh, you know why? I bet you because I still have the access match protocol. So let me come down to here. I type in no and pull this out. And exit out control plane. Service policy input is going to be ping. There we go. So now we type in show service policy. This is show dash policy. Is that the no? I'm sorry. Show policy map. So now we have this right here. So now if we go to 2 and we try to jump out of here and type in ping 10.1.100.1, and we try to do this, and we try to say repeat is 10,000 with a timeout of 1. I don't know. I don't think it's going to affect it. What if we do? Let's see. Show class map. Show access list. Is it even triggering it? Yeah, it's not even triggering it. But anyway, the idea here was to try to, and I'm sending all these pings and it's working out quite well. So my pings are working. The point of that was to try to block ping from reaching that device. So I'd have to actually play with that to figure out what the actual right configuration would be, but that would be the idea behind it. And you've actually already seen me mess with a couple access lists. So a standard access list is going to be an access list that matches based on the source of the traffic, to be placed as close to the destination as possible for obvious reasons, because the closer you place it, the more specific the match will be. An extended access list is going to allow you to match on the source and destination, and the not only the source and the destination, it will also allow you to dig into it's an IP access list. Where standard access list focuses on the entire IP stack, so IPs, TCP, UDP, ICMP. Where in extended access list you can get granular and talk about just TCP or just UDP or ICMP and things like that, and it gives you that flexibility to go in there and manipulate what you need to. The one that a lot of people don't know about is the time-based. So if we come up here, we type in time-based, time range, and we give it a time. We'll type in, CCNP, hit the enter key. Here we can specify when we want something to happen. So at a certain time of day, let's say for instance you want to restrict the use of Gmail and Yahoo email and things like that on your network. Well, what you could do is you can go in there and create a time range and say from 8 a.m. to 5 p.m. Monday through Friday, you will deny any traffic destined to a group of block of subnets that Yahoo and Gmail use for connectivity. Once you have that in place, you can attach the time range to an access list. And that would allow you to specify a time range to it. So that would give you that flexibility. So, and there's a question: how would you apply that? You would just create the configuration. So if we were to exit out of here and type in IP access list 20 or standard 20, type in permit any question mark log, and actually it won't let you do it here. IP access list extended 200 or 100 and type in permit IP any time range. It'll allow you, in CCNP, it will allow you to come in here and specify that traffic will only, that the ACL will only be matched if the time range is active. So that'll give you that flexibility in case you're trying to be specific on a particular set of traffic. So the last one we're going to talk about here is going to be IPv6 traffic filters. And I think it's kind of applicable because of the fact that what we have going on here. But the idea here with IPv6 access list is going to be IPv6 access list. And you only have the named access list. So we're going to type in CCNP question mark and hit the enter key. And here you get to do we're going to permit IPv6 any, and then we're going to say underneath the interface Ethernet 1/0, you would type in IPv6 traffic filter, and then you would call the name of it, which is going to be, I believe I named it CCNP, and hit the enter key. In. So now we have that. And remember, the one thing, this applies just like it does in IPv4, where you can only place an ACL, one ACL name per interface per direction. So what that means is if you have the same one, you'd have to place another one. If you had an inbound, you have to place another ACL on this interface in the other direction. So it does give you some flexibility here, and that's basically what you would do. So everything else works out from there. If I was to do a trace route to 2001:108::10, I'm permitting it if I type in show IPv6 access list. We have 29 matches, and we have on sequence 10, so that means our access list is working. Even though we're doing a permit everything, it's still going to log it for us. So that's how that would work. The last thing we're going to touch on is going to be unicast reverse path forwarding. Now, unicast reverse path forwarding, basically the idea here is if you receive a packet in on an interface, the idea here is you want to make sure that you can use the IPsef table. We talked about Ceph earlier. That if you when you're forwarding traffic back out towards the source, because you're essentially the destination. If you're forwarding traffic back towards the source, it had better be leaving on the same interface it came in on. So they call a reverse path forwarding check. And we'll talk about multicast in an upcoming video. But the idea behind this is if I learn traffic in on, say, interface Ethernet 1/0 from router 7, my reverse path my reverse path back to 7 should be at Ethernet 1/0. If that is not the case, then you can drop the traffic, and that's if you're using strict mode. And the way to configure that would be on here. Type in interface Ethernet 1/0 and type in IP verify source or unicast reverse path, and you can say how you're going to be able to get back to the destination. The other one here is going to be the source, and you can say reachable via, and you can say any. This is using the any command is going to allow you to. It's called loose mode, which means as long as you have a reverse path back towards it, it can be received on any. Is reachable via any interface. Where the receive, this is strict mode. Source is reachable via interface on which packet was received. So basically, you have to go back out the same interface you received the traffic in on. So basically, the idea behind this is to prevent. They call them bogans and Martians, for where you might receive the 10 network in on your interface, where no RFC 1918 space should be advertised into the global routing table. But it does happen every now and again. And the most common thing that I've seen it happen in is MPLS VPNs, where the provider accidentally route leaks traffic into a VRF, or I should say out of a VRF into the global routing table. It's I haven't seen it in quite some time, but I know I've worked with some engineers in the past that were telling me about it. And like I said, I've never seen it myself, but the most common time that it has been seen is with MPLS VPNs. So it's not common, but it could happen. So that's basically URPF. So I just want to make sure you guys understood how that would work. So, and again, it's to prevent against spoofing attacks. So if you're receiving traffic in from somewhere and you don't know how to get back to them, the RPF check would fail. So that's the security video. I told you it wouldn't be very, very long. It's about a half hour, and I covered all the content that I wanted to. I hope this has been informative for you, and I'd like to thank you for viewing.